let's talk about how to write chemical formulas for ionic compounds. So what this means is that we're going to start with a chemical name, like magnesium chloride, and learn the steps that we have to go through to take this chemical name and use it to write a chemical formula, like MgCl2. Okay? Let's start with our first example, lithium oxide. So when I'm doing these kind of problems, the first thing that I want to do is find both of these elements on the periodic table. I'm using this kind of weird version of the periodic table that I just wrote out. I left out a lot of the elements because they're not important for what we're doing here, and I thought they were kind of distracting. But don't be confused. This really is no different from the periodic table that you probably have in your book. It's just that it's missing a lot of the elements. Anyway, lithium. Want to find that? It's right here, Li. And oxide. Oxide is just another word for oxygen. It's what we call oxygen when oxygen has a charge. I'm going to talk a little bit more about that later. Anyway, oxide is just another word for oxygen, and oxygen is over here. They're on opposite sides of the periodic table. And check this out too. There's this big, thick staircase that separates lithium from oxygen. What's a staircase doing? Well, if you remember, the staircase separates the metals on this side of the periodic table from the nonmetals on this side of the periodic table. So lithium's a metal and oxygen's a nonmetal. This is important because we have a metal and a nonmetal connected together, and that means that we're dealing with an ionic compound. Ionic compounds are always metals and nonmetals. So when we have metals and nonmetals making an ionic compound, that means that the atoms in that compound have a charge. So I want to find out what the charge of those atoms is, and I can do that by looking at where they live, what column they live in on the periodic table. Here's what I mean. So lithium lives in this column. Everything in this column has a +1 charge. So I'm going to write this right here, Li 1+. Everything in this column has a 2+ charge, 3+ charge. You might want to write this on your own periodic table that you have for your reference. Everything here has a 3- charge, and oxygen, which lives in this column, has a 2- charge. So I'm going to write it right here. So Li 1+, O 2-. Okay, so now I ask myself, does the plus charge and the minus charge balance when I have one atom of both of these? The answer is no, because I have 1+ charge, but I have 2- charges. So the charges don't balance. But I want to figure out how to balance them. I need to have them balanced in order to write the chemical formula. So what I can do is I can add more lithium atoms, I can add more oxygen atoms, or I can add both of them until I get the charges to balance out. I have 2- here and only 1+ here. So what I'm going to do is I'm going to add another lithium atom, Li+, so that now I have 2 positive to balance out my 2 negative. And now they balance. So in order to get the charges balanced, I have to have 2 lithiums and 1 oxide or 1 oxygen. Now when I write the chemical formula, I'm literally going to say how many of each of these atoms I need in order for the charges to balance. And we've said that's 2 lithium atoms, so I'm going to write Li and then the 2 after it. That indicates that I have 2 lithium atoms, and then 1 O to show that I have 1 oxygen, and I'm not going to write anything after that. If you have a letter without anything after it, it means that you just have one of them. So lithium oxide, 2 lithiums and 1 oxygen is how we get the charges to balance for this compound. Here's the next one, potassium nitride. Just as before, I'm going to take out the periodic table and I'm going to find both of these guys on it. Potassium is K. It's right over here, and nitride is what we call nitrogen when it has a charge on it, and so nitrogen is over here. Check it out. Metal, nonmetal, separated by this big thick staircase, so we know we're dealing with an ionic compound, and whenever we think ionic compound, metals and nonmetals, we want to think charges. What charges do the atoms have? Potassium lives in this column here, the same column as lithium, and so it has a 1+ charge. So I'm going to write that up here, K+. And nitrogen lives in this column where everything has a -3 charge. So here we have N 3 minus. When I have one atom of K plus and one atom of N3 minus, do the charges balance out here? The plus and minus, does it balance out? It doesn't. I've got 1 plus and I've got 3 minus. That doesn't balance right. But I can add more atoms of either type in order to get the charges to balance. So since I don't have as much plus as I have minus, I'm going to add a bunch more potassiums. Here I add another. Now I have 2 plus. Now I'm going to add one more. Now I have 3 plus. The 3 plus potassium on this side balances out the 3 minus nitride on this side. Now when I write my chemical formula, I want to literally say, how many atoms of each type do I need for the charges to balance? I'm going to need 3 potassiums, so I'm going to write K3, and I only need 1 nitrogen, or 1 nitride. So I'm going to write N with nothing after it. If I don't write anything after it, it means 1. So 3 potassiums, 1 nitrogen. The correct formula for this is K3N. Okay, here's another one. Sodium chloride, which is the name of common table salt. Once again, I'm going to find them both on the periodic table. Sodium right here is in the 1 plus column, and chlorine or chloride is in this column right here. We've got metal and nonmetal, so we're dealing with ionic compounds, which means the atoms have charges. Now I want to figure out what the charges are. As I said before, Na is in the 1 plus column, so an atom of sodium has a 1 plus charge here. And then chloride is what we call chlorine when it has a charge, and chlorine lives in this column, so it has a 1 minus charge. So Cl 1 minus. Okay, so now I have 1 atom of sodium plus 1, and I have 1 atom of chloride minus 1. When I have an atom of both of these, does this positive and negative, does it balance out? It does. I don't need to add more of either one of these atoms. I'm totally set. So to write the chemical formula for sodium chloride, I want to say again, how many of each I need for the charges to balance out. I'm just going to say NaCl. I don't put any numbers after them, because if I don't put a number, it means that I just have one of them. So I have 1 sodium and 1 chloride. Okay? You might be getting the hang of this. I want to try to convince you to watch this one last example because it's a tricky one that confuses a lot of people. Okay. Aluminum oxide. Once again, periodic table, aluminum here, oxygen here. Metal, non-metal, it's ionic, which means charges are important. So aluminum is in the 3 plus column. 1 atom or an ion of aluminum. An ion is just what we call an atom that has a charge. An ion of aluminum has a 3 plus charge. And an atom of oxygen, oxide here, has a 2 minus charge. Al3 plus, O2 minus. Now I need to figure out how many of each of these atoms I need for the charges to balance out. And this example is a little bit trickier than the ones before. How are we going to be able to add atoms to get the same number of positive and negative charge? Let me give you a hint. We're going to start by adding another aluminum atom in here, or aluminum ion to be precise. So now I have 3 plus here and 3 plus here. Each aluminum atom has a charge of 3 plus. So I have a total of 6 plus. Now I can balance out the 6 plus by adding more of the oxygen. I add 1 more oxygen, I have a total of 4 minus. And I add 1 more, I have a total of 6 minus. So this is how we balance out the charges in aluminum oxide, with 2 aluminum ions with 3 plus each, total of 6 plus, and 3 oxygen ions with a total of 3 oxygen ions with a total of 2 minus each, which gives us minus 6. Now I'm going to write the chemical formula to show how many of each I need to have. That's going to be Al12 and oxygen 1, 2, 3. I have 2 aluminums and 3 oxygens. Okay, so now let me tell you what I'm going to do. If you're still a little bit shaky on this, I'm going to do a few more practice problems in a minute. If you feel really good about this, you might want to just turn the video off and go and watch the videos that I have on writing formulas for compounds with transition metals and for compounds with polyatomic ions. But before I do a few more practice problems, I want to talk about two commonly made mistakes so many people make when they're writing these formulas. So you might just want to stick around to watch that. Here are the two mistakes people make. Let's assume that you're asked to write the chemical formula for lithium oxide, and you do this, you find out that you want to have two lithiums with 1 plus each to balance out the charge on oxygen, okay? Here is one mistake that people make. They say, okay, I have 2 lithiums and 1 oxygen, so I'll write Li2O1. They say, yeah, there's only 1 oxygen, so it can't hurt to just add the O1 here, can it? It can't hurt. It does hurt. It's just not right to do. You never want to put a 1 after an element. So Li2O1 is wrong. Instead, you want to write Li2O without any numbers after this, and this is the right way to do it. Here's another mistake that people often do. They don't remember to get rid of the charges when they write the chemical formula. So they end up writing something like Li plus 2, O2 minus, where the charges that were on the atoms here stay when they write the chemical formula. This also, unfortunately, is wrong. When you write the chemical formula, you want to get rid of all of the charges. So you just write again, Li2O. Make sure there aren't any charges in the chemical formula when you finally write it. Okay?